Hello, I'm George Gonzalez, and I'm a VR developer. I'm obsessed with making games, and in the last 4 or 5 years, I've been working on building, publishing, developing games for Meta and Steam. I've worked on Sail VR single player, Monkey Doodoo, a multiplayer VR game, Cactus Jam, another VR multiplayer game, and now my own VR title called Magic Hunters. So I've been working with the Meta Store, the developer dashboard, in-app purchases, all these topics, and I'm very familiar with the VRCs, profiling, and optimizing for VR. What we're going to talk about is VRC.Quest.Performance. And as I was preparing for this video, I realized that these tactics and issues that come up are universal. Whether you're doing mobile, VR, or PC, you will always try to find whether you're GPU or CPU bound. You also want to know how to best improve performance. And also, it doesn't matter if you do it in Unity or Unreal Engine or Godot. The tactics are the same. But today we're going to talk about Unity in VR and with Meta. At the end of the discussion, we will talk about how this relates to all the other platforms, all the other engines. But let's start going. We're going to go one by one on these. This is going to be super fast video, but I promise you that you will get exactly what is in the thumbnail. First off, we have VRC.Quest.Performance 1. The app must run at the specified refresh rate. This is a must. Now, in the past, there's been some stories or rumors about what this meant. Because before, when the Quest 1 started, the bar or the refresh rate was always 72 frames per second. And you could push it to 90 with some devices or in PC VR. And so this was kind of ambiguous because what developers would do when the Quest 2 came out is they would push the boundaries to 90 frames per second on apps, and they would be able to meet the criteria for 72 frames per second. And so most developers thought that if the app ran above 72 frames per second, everything was fine. But the reality is not. That's not the VRC. This VRC, what the Meta is trying to say is whatever refresh rate you specify for your app at the beginning of the game, if it's 72, it must stay within those 72 range. If it's 90, then it must stay there. And if it's 120, it must stay there. So the idea is that they don't want the frames to drop drastically. So wherever you set your frame rate, 72, 90, or 120, you have to keep the app at that rate constantly. So you can't just boost it up to 120, and if it goes down to 80, be okay with that. Meta's going to flag it, and it's going to tell you that it didn't pass this VRC. So you got to make sure that whatever you set out, usually also you have to take into account battery usage. If you up the frame rate, you'll probably be using more battery life, and so be aware of those things. The main thing is the refresh rate to whatever you think is adaptable. Usually 90 is now a good medium, since there's a Quest 2 and Quest 3 can both handle that. 72 is also a fine standard to set. Now, let's go to the VRC.Quest.Performance 3. This one's super simple, but it's just, if you are in Unity or Unreal, most of the time, I know Unity at least, when you create a VR rig in Unity and you hit play, it already is detecting the headset and it'll track to the headset. So this VRC that you must have a display head tracking graphic in the headset within 4 seconds. That is being taken care of by Unity by default. So you're fine with that. You don't have to worry about it. Now, if you have a lot of things that you're loading on the first scene, I would suggest that you probably want to alleviate that and move things to a different scene that the first scene loads. It doesn't take forever to load. That won't mess up with this, the VRC. The last one, which is plus, you don't have to do it, but usually we'll talk about this and I'll show you what I mean. This is about the GPU and the CPU. Usually what happens is you can set the render scale to render less, and that will optimize performance. What used to happen is on Quest 1, there was a time where you couldn't choose whether to make an app for the Quest 1 or the Quest 2. You had to do it for both, or else you wouldn't be able to push your game to App Lab or Meta. And so what people would do is they would change the render scale to like 1 or 0.1 so that it wouldn't render anything Quest 1. Because at that point we knew that not many people had Quest 1s. Quest 1 was old, outdated, and everyone had a Quest 2. So most of that's how people did it. But this rule is to help developers create good games with good graphics. Anything below 85 usually means that and it doesn't look as good. So let's talk about this, because this goes into the next topic that I want to bring up is bottlenecks in GPU and CPU, how to use this render scale to really optimize your game, or at least profile it. Because while you're in the topic of performance, I want to talk about debugging, profiling to know where is the optimization that you need. So first of all, let me show you that render scale. So if you go to project settings under the graphics, you'll see the scriptable object for the URP pipeline. And in here, if you click that, you'll see in here there's a render scale. If you're in an older version of Unity, you'll have this in the camera settings. But you can, this is what it means by saying no less than 85. So this is 83, this is 80, so this is all lower. This is not good. So if I play my game, you'll notice if it's saved, I think it'll save the asset. Now what you will see is that, see how it's super pixelated? This is what happens when you set it to that render scale, okay? Everything's super pixelated, and you can't see because I don't have like any lights on this right now. I could turn this directional light to maybe. But anyway, so right now everything here is pixelated. If you can see it, you'll see that it's super pixelated. Anyway, so if we go back here and we change it, I think it's we can go back to 1 or 2, whatever right now. So if we do this, you'll see that it'll go back. So the idea is that it renders less pixel, it scales down the image, and now it's super crisp, okay? And you'll notice, if you can see, sorry, it's just that in VR, that's enough lighting. Okay, so that's the game. So what does that mean for VR? When in VR, usually, and in any game, the tip now is, how do you know where the bottleneck is for performance? Okay, I'm gonna give you something in here. I'm gonna give you a link in the comments below. This amazing video for optimizing for Meta Quest for the VR, and this is useful for anybody, regardless of where. So let me move myself. Okay, this is amazing. This is for anybody, regardless if you're VR, mobile, anything. This is how you go through to know if you're CPU bound, GPU bound, or even like vertex and fill bound, and what to do. And this is where the render scale comes into play. And that's why I want to share this with you, because this performance led me to think about, okay, optimization, not just optimization, it's just how do you determine where you need to improve for performance? Because oftentimes people will start touching things, they'll go straight to the profiler and try to figure out what's wrong, and they don't see anything, and they're trying to like decipher, okay, this is 100% accurate in determining what's going on. Okay, I'll leave a link to the video so he'll talk in detail about this. But the idea is, okay, so first you're like, okay, am I CPU or GPU bound? He'll go through and he'll disable all rendering. Like he'll disable the cameras. And so when you go into VR, you can't see anything. If you have a specific scene that is a hiccup, you can just load the game into that scene and create a build just for that. But the idea is that you're going to navigate this game in VR, or you're going to just load whatever scene is the performance issue, and you're not going to have any rendering. No. If this actually improves your performance, which usually it does, because most of the time it's our assets that's killing your game. So what happens is that usually, yes, and so you're GPU bound. If not, you're CPU bound. So for example, if there's physics or other scripts, like if you're running an infinite loop that's not getting anywhere, and it's constantly iterating and creating memory leaks or doing something, then you'll see that it'll still chug when there's no camera. So that means there's something in the code. So that's how you know if it's in the code. You disable the cameras, and if performance doesn't improve, it means a script is the culprit. The other one is if it's yes, if it does improve, then you have something with the render, the mesh or something. So you need to figure out, okay, am I vertex or fill bound? Meaning in here, do I need to simplify geometry or do I need to simplify the shaders? And the way you do it is with the render scale. So if you lower the render scale to 0.01, like we were talking about before, you use this trick that we just did to figure out, okay, like where, if the 0.01 improves dramatically my frame rate, then I'm fill bound. This means that there's something wrong with the shader. Okay, if the render, because this is how things are being rendered, and if you do 0.01, it means that there's less to render, but there's still something. Each one of those rendering is taking a lot, so there's something heavy in those pixels. Now, if you're vertex bound, it means that you have too many draw calls or geometry, too many vertex. So you can optimize your geometry. This is amazing to do because a lot of developers will start optimizing things for the sake of optimizing, but you don't know what the bottleneck is. The bottleneck means that there's something in there that's the culprit that's taking out probably 80 or 90% of your resources. And the moment you find those, it it makes it so that instead of working on 100 different optimization techniques or doing them all just for the sake of doing them, instead of doing that, you just do the one thing that will bring you the most bang for your buck. So you're gonna analyze it, you're gonna determine what it is, and you're gonna solve it. Done. And so this is amazing. I'll link the video below. But this is why I wanted to bring this up for performance, because whether it's meta in Steam, mobile, either Unity or Unreal, this is huge. And it's not just a VR. It is a VRC, but it's not just a VR problem. It's a game problem in general with limiting factors. And because we have more GPU, more CPU in games, and better phones, people think that they can just avoid this and just run until they hit the limit. But the more optimized you are with your games, the more you can do, the more you can explore. You can do the visual effects, you can do all the crazy stuff that you want to do with physics, but you have to know where your bottlenecks are so you can save on performance. So hope you like this video. If you have more questions about performance or any other VRC or your game in general, let's talk about it. Comment below, let me know. If you like these videos and they're actually helping you, please give a thumbs up and subscribe. Let's get your game finished and looking good.